Okay, good afternoon or morning, everybody. It's Sunday morning, about 10:30, so daylight savings time. So I'm all discombobulated, but hopefully I will be organized enough to talk to you about this core concept, which is all about analyzing the discriminant. And essentially, what we can do is we can look at what's called this thing called the discriminant, and just by working with the discriminant, we can decide how many solutions we can have for our quadratic equation. Remember, we can have 0, 1, or 2 real solutions. We can also have no imaginary solutions, which means we'd have 2 real. We also can have up to 2 imaginary solutions. So, summary, we can have 1 or 2 real solutions, or we can also have 2 imaginary solutions. And so I want to talk about how we can do that just by looking at the discriminant. So the first thing I think we need to do is define what the discriminant is. And the discriminant is this piece right here, the b squared minus 4ac. That piece of the quadratic formula that is underneath the square root sign. And you can see right here I've got it rewritten 3 times. And what we want to look at is we want to look at when the discriminant is greater than 0, when the discriminant is less than 0, or equals 0, and when the discriminant is less than 0. So let's start when the discriminant is greater than 0. Okay? If you were to chunk out b squared minus 4ac, and remember this is once again dealing with y equals ax squared plus bx plus c, our quadratic equation. If b squared minus 4ac is greater than 0, you're going to end up with what's called 2 real solutions. So 2 real solutions. Okay? And that means you're going to get an answer like 3 and 7. Okay? So your numbers are going to be real numbers. Now, what does that look like? Remember solutions on the graph. Solutions on the graph are x-intercepts. So remember when you solve these things by graphing, essentially what you're looking at is you're looking at where it crosses the x-axis. So anytime you have 2 real solutions, anytime the discriminant is greater than 0, your graph is going to cross the x-axis in 2 different places. Now, I put one over here on the left side of the y-axis and one over here on the right side of the y-axis. They could both be over here. They could both be over here. That's okay. It's also very possible that our parabola could be upside down, and then once again it could be both could be on one side or the other, or split like that. Okay. So that's one way we can analyze the discriminant, just to determine the number of solutions that we have. The second situation is when the discriminant equals 0. And that's where we have 1 real solution. Okay, so we just have 1 answer. That would be something if we were solving it algebraically. If I had like b plus 3, the quantity squared. So the b plus 3 is in parentheses, then a squared. Notice you always get a repeated answer. What that looks like on the graph. Oh boy, my pen's dying here. Alright, pause. Let's see if I can find another pen real quick. Ooh, got a couple of them. So let's see if some of these work here. Alright, let's try this one. Hey, we got one that works. Thank goodness. Okay, so if there's my graph, if I have 1 real solution, basically your vertex is what touches the x-axis. And so then your parabola will come up like this. Now, once again, it doesn't have to be on this side of the y-axis. It can be over here also. This could also be flipped upside down. Okay? The third situation is when our discriminant is less than 0, and that's where we're going to get 2 imaginary solutions. Okay? And remember, when we have imaginary solutions, what does our graph look like? Our graph does not touch the x-axis at all. So it could be something where our parabola is like that. Okay? It could also be over here, down here, or down here. Doesn't matter. Okay? But what this will allow us to do, and something that we're going to work on not only this unit, but also in future units, is being able to look at an equation or a function, look at this, and determine how many solutions does it have. Well, for quadratics, there's an easy way to do it. We look at what's called the discriminant. If the discriminant is greater than 0, we're going to have 2 real solutions, which means we can come up with 2 real number answers. If the discriminant equals 0, we're going to have 1 real solution. So like x equals 4 would be 1 solution, and that's it. And then if the discriminant is less than 0, we're going to have 2 imaginary solutions. So something like 3 plus or minus the square root of 7 would be 2 imaginary solutions. Okay, that's all I have for you. Enjoy.